Hi, my name is Miguel Guzman, and I will be talking to you about our National Academy of Engineers Grand Challenge, Making Solar Energy Economical. First, what is solar energy? Solar energy is energy provided by the sun. This energy is a form of solar radiation which can be converted into thermal or electrical energy. Why is solar energy important? Solar energy is the cleanest and most abundant renewable energy source available, but we only use less than 1% of the total energy consumption compared to oil, natural gas, and coal. Why, you ask? Well, it is an expensive process from capturing the sun's energy, converting it to useful forms, to storing it. How efficient is solar technology? Today, solar cells that are made of silicon can convert sunlight into electricity with an efficiency of 10 to 20%. With the manufacturing cost of today's cells, we can produce electricity at a cost of 3 to 6 times higher than conventional electricity. To make it more efficient, we have to come up with better solar cells that produce better percent efficiencies. How do you make solar energy more economical? Current solar designs require very pure and expensive materials because impurities block the flow of electric charge. If we cut the distance and narrow the material the charges will have to go through, then maybe we can cut the cost. The problem with this is that narrow layers will not absorb as much sunlight. How do you store solar energy? Along with trying to make it more economically, how do you store solar energy? Along with trying to make it more economical, we also have to worry about storing it. If we stored energy by generating another source of fuel like plants do during photosynthesis, we can store and produce fuel at the same time. In conclusion, making solar energy more economical is a very difficult process and involves a lot of different steps to achieve this goal. We created a code to show the different capacity factors and the storage energy for different countries, which I will now talk about. For our project, we are using megawatt hour per year to plot our graphs. In our output statements, we have converted megawatt hour per year to terawatt hour per year to better format our numbers, to show our max energy storage, our min energy storage, and our average energy storage of each country. And now I will turn over to MATLAB and talk to you about our code. So when plotting the bar graph, MATLAB is going to call on the function country according to which country the user chooses. And is going to plot markers also because some markers might not show up on the bar graph due to really low values. So the axis for the x-axis is going to be from the minimum of the x value minus 1 to the maximum of x value plus 1. And the y minimum is going to be the minimum of the y value all the way to the maximum of the y value. So the axis is going to show x min to x max for the x-axis, and for the y-axis is going to be from y min to y max, and the x label is going to have class number, y label is going to have the energy produced per year in megawatt hour per year. So after the bar graph is displayed, three more different outputs in the command window are going to show up. The sum of the data of that country, the average of the data of that country, and the maximum data of that country. So after the bar graph is displayed, three different outputs in the command window are going to show up. The sum of the energy stored of each of all classes and the average energy stored of all classes and the maximum energy stored of each country. After the bar graph is displayed, three different outputs in the command window will pop up. The sum of the energy produced of every class, the average energy produced of every class, and the maximum energy produced of each class of all the classes. So for our outputs in our command window, we converted them to terawatt hour per year, and for that we created another function called data, which is here. So for the function data, for the sum from megawatt to terawatt is 1 million. So the sum is going to display the sum in megawatt, and we are going to divide it by a million, which is going to give us terawatt. And same for average, same for max. It's going to give us these outputs right here. And we do this for each case in each country. So let's run this. So as you can see, the menu pops up. What is the letter of the country you are looking for? Let's pick Afghanistan. And then let's pick A. So what country that begins with the letter A are you looking for? Afghanistan. So as you can see, the bar graph is plotting, for class 1, the values and everything. And then here it says, would you like the data that is being saved into data log deleted? No, because I want to save this data, right? And if we look in our command window, it says you have picked Afghanistan. The total energy produced in the country is 4,875,623 terawatt hour per year. The average energy produced in the country is 696,518 terawatt hour per year. And the maximum energy produced by one class in the country is 3,079,034 terawatt hour per year. So we keep running it. We run it again to F. We get Fiji and France. We pick France. Different plot comes up. And again, it's asked us what if we want to say, if we want to delete our data. No, we don't want to delete it because later we want to compare it to Afghanistan. So again, you picked France, so it's going to show us the total energy, the average, and the maximum of France. So let's run it one more time. And let's pick the United States. Here is the United States right here. Would we want this data deleted? No. And it shows us all these, our total, our average, and our maximum. So if we look at our current folder, we see our diary data log, we open that up and it's going to show the first one we picked, the second one we picked, and the third one we picked. And then we can compare the values for that. So as we can see, the USA clearly stored more energy than France and Afghanistan. Or if we run it again and we just want to look at a country, but we don't want to save the the data in our diary, we can look at that. As you can see, it plotted the bar graph and it shows the the total energy, the average, and the maximum energy produced. But when it asks us, yes, we want to delete it, it doesn't show up in our command window, in our data log diary window. Excuse me. So if we were to run it and say, for instance, the user picks the letter X, no country starts with the letter X. In our command window, we would get an output statement saying no countries with the first letter being X is outputted. In conclusion, you might be asking yourself, why or how can we use this code or this data we have provided to you? Well, let's say somebody is researching how to make solar energy more economical. First, they will have to know which countries are producing the most solar energy, correct? So, using our code, they can pick which countries they want to compare, and from those, they can see what countries produce more solar energy, and then they can make an assumption being why are they producing more solar energy? Is it because they have more money to spend, or did they find a better way to store it or to produce this solar energy? And then that person can go to that country and see their resources, see how they did it, see how they're doing it, see what they are doing to make it better. Once we figure out what these countries are doing and or how they are doing it, we can use that information to try and make it better, to make it even more economical if they haven't already done so. We can get together as a whole to try and figure out the situation, because if we find a way to make solar energy economical, we will have an unlimited resource, because solar energy is abundant, like, and it's free, because all around the world. It's it it's just so much we can do with it. We can, and there's so much of it that nothing can really compare to it if we find a way to cheaply or more economically store it and use it and apply it